ये ब्रेक के बाद जो भी हमने किया वो सारा रिपीट करें. ओके. There is one modification which need to be done. Basically, if you subtract the yt minus 1 on both sides, you will get this thing yt minus yt minus 1. This is equal to rho yt minus 1 minus yt minus 1 plus epsilon t. So you can write this as del yt is equal to here the rho minus 1 into yt minus 1 plus epsilon t. Okay. So I can write this as del yt is equal to rho star into yt minus 1 plus epsilon t. So what was your hypothesis? The hypothesis was rho equal to 1. If rho is equal to 1, this was your null hypothesis, and the alternative hypothesis is rho is less than 1. So if rho is equal to 1, then rho star will become 1 minus 1, 0. And if rho is less than 1, the rho star will become less than 0. So the hypothesis is transformed into rho star equal 0 versus rho star less than 0. This means unit root, and this means stationary. So far, you have the idea how to apply unit root. But there are many other problems as well in the whole this analysis. What are those problems? For example, we have discussed that you may have a generalization this is your generalization yt is equal to alpha plus rho yt minus 1 plus epsilon t. This is called, you have intercept here. And you may have a third format, yt is equal to alpha plus beta t plus rho yt minus 1 plus epsilon t. This is your intercept plus trend. And in all these cases, the stationarity is depending on rho. In all three scenarios, the first scenario is yt is equal to rho yt minus 1 plus epsilon t. In these three scenarios, if rho is less than 1, then you have stationary. It's more appropriate to term as trend stationary, because in the third scenario, you don't have absolute stationarity. You are going to discuss yt, this is del yt. Understand? From this calculation, you have to infer about this yt. And even if this is stationary, this can have some other thing. If it is white noise, this is having other properties because this is dependent on lag. Okay, so you have trend stationarity. For that, you require this rho to be less than 1. And for the unit root, you require this rho to be equal to 1. But the issue is, what is the most appropriate regression that you will use? should you use this form or this form or this form? Which form is most appropriate? This is the question. So, whenever there is question and you are finding the answer on the basis of statistics, there is some probability of error, type 1 error or type 2 error, etc. And if you are doing the procedure 2 times, the probability of these errors will accumulate. And if you are doing the procedure 3 times, the probability of error will increase further. So ultimately you don't know what is the probability of error. All these things become so vague that it is very hard to conclude something sensible out of the data that you have used. For example, first we have to decide, should I use equation number 1 or equation number 2 or equation number 3? And then there is one more decision as well. Basically what happens, so far we have assumed that this epsilon t is white noise. Okay. If this is not white noise, if this is having autocorrelation but this is stationary, again you will have same phenomena. If epsilon is stationary, means there is autocorrelation, then what will happen? Again, rho is determining the status into I0 or I1. But for this, you have to specify how many autocorrelated legs are there. If there are 2 autocorrelated legs, you are including 1, then the power will be lost. If there is 1 autocorrelated leg, you are including 2, again power will be lost. So this is another decision which you have to make. So all these decisions give you some probability of errors. It may be type 1 error or it may be type 2 error. But collectively, all these probabilities of error will sum up to very huge probability of error, and you don't know what exactly the probability is. Because for the real data, you don't know what exactly is the data generating process. When you don't know which scenario is most appropriate. That gives you the I have my own perspective on this, which is different from what is written in the books. And I will explain my perspective in details because this is otherwise not available in the books. Basically what happens, suppose you have a series like this, yt equal alpha plus beta t plus yt minus 1 plus epsilon t. Here the coefficient is 1. Okay. I am back substituting value of this thing. It will become equal to alpha plus beta t plus alpha plus beta t minus t plus y t minus 2 plus epsilon t. I have put the value of yt minus 1 according to this formula here. Okay. So what it has become, this is 2 alpha plus 2 beta basically this big जी कहाँ पे ओ हाँ यहाँ पे एप्सिलॉन t minus 1 भी होगा and in this way you if you back substitute every time you will get accumulation of this okay. And when you get basically this becomes there is t plus 2t plus 3t plus 4t and so on. If you back substitute to the end, you will get the things like this. And this is equal to, there is basically this is harmonic series, arithmetic series, and if you take the sum of this thing, this will become t into t plus something. So ultimately it will converge to t square.